So in this video, we're going to be working with simplifying radical expressions. We have been working, or we have worked before with simplifying the square root, but now we're going to simplify a radical expression that my index is different than 2, right? And then the index is how many times that number has to multiply, right? So the square root, for example, the square root of 16 equals 4, because if you multiply 4 times 4 is 16. So now I'm looking for a number that you multiply 4 times itself to be 64, right? So there's no such whole number. So in this case, we don't have a perfect fourth root of 64. We need to simplify. To simplify, I'm going to use prime factorization. So first of all, I'm going to start by factoring out by 8. You can use any one. The prime factorization at the end is going to be the same. So this is 4 times 2. This is 4 times 2. And so this is 2, 2, 2, and 2. So my factorization, I'm not going to write it with exponent, and I'm going to show you why later, right? So in this case, it's 1, 2, 3, 4, 5, 6. So it's 2 times 2 times 2 times 2 times 2, right? Now, I'm going to form groups of 4, right? So I'm going to form group of 4. So I have 1, 2, 2, 3, 4, right? So that means that I have a group of 4. Why 4? Because my index is 4. So that means that I can factor out 1, 2. So I'm going to have 2, the fourth root of whatever is remaining. So in this case, it's remaining 2 times 2, that is 4. That is my simplification of the fourth root of 64. So the next one, 3020. Again, I'm going to start by 320. So this is 32 times 10. So this is 2 times 16. This is 2 times 4. It's 2 times 2, or 2 times 8, sorry. So this is 2 times 4, and 2 and 2. And this is 2 times 5. So that means I have 1, 2, 3, 4, 5, 6, 2 times 5. Now, I'm going to form group of 3. Why? Because my index is 3. So that means that I have one group of 3 of 2. So let's write this one here, 2. Now I have a second group of 3 of 2. A group of 2. So I'm going to multiply that. And now inside of the radical, I have that 5 that is remaining there. So that means that this is 4, the cubic root of 5. Now, the next one, again, now I have a square root, right? Because I don't have to write if I don't have the index, that means I have a square root. So 32, that one is easy. We know that is 16 times 2. We don't have to do the groups because we know how to simplify a square root. So negative 7, square root of 16 times 2r. So this is the same as negative 7 times 4, square root of 2r. So this is negative 28, square root of 2r. That's it. See? So let's start with the number. So 4, 4, 8. So 448 is 64 times 7x cubed. Right? So this is 3 times 4. Now the variable that has its exponent is greater than or equal to the index. In this case, remember that it's square root, so it's 2. So that one is greater. I'm going to do the following, right? I'm going to take that exponent and I'm going to divide it by the index. So this is 1 minus 2 is 1, right? So the quotient is going to be my exponent of the variable outside, and my remainder is going to be my quotient of the variable, or the exponent of the variable inside. So that means that this is going to be x to the first square root of, remember that we have the 7x, right? But in this case, I need to make sure that that variable is always positive, right? Why? Because this is a square root. So that's why it's going to be the absolute value of x. So this is 12, absolute value of x, square root of 7x. When I'm using the absolute value, when the index of my radical is even and the exponent outside is odd. Next one, this is 8. Square root, we know that this is 4 times 7, x, y squared. Right? Now, so I have 8 times 2. The 2 comes from the square root of 4. X, the exponent of x is less than the index, and the exponent of y. So the square root of y squared is going to be the absolute value of y. And again, remember inside we had the 7x. You have to multiply first. So this is 16. Absolute value of y is square root of 7x. Now we complete the exercise. Again, 16, we know that has a perfect square root, 4 times 4. So 5 times 4. Now, again, 3 divided by 2, so 3 divided by 2 is 1, minus 2 is 1. So have the absolute value of x. And 4 divided by 2 is 2, so that means y 2. And remember that we have a and x reminded inside. So 20, absolute value of x, y squared, square root of x. As you can see, this one, because the exponent outside is going to be even, we don't need to include the absolute value. So now my index is 4. So my index is 4. So now 32, remember that is 16 times 2. So 2 times 8, 2 times 4, 2 and 2. So I have 2. Right, so 5. So I'm going to form groups of 4. So I have 1, 2, 3, 4. So that means that I have a group of 4 too. So that means that I'm bringing out times 2. Now the m, the exponent is less than the index. So that means that I'm keeping the same. N to the 4 is divided by 4, right? So this is n, the absolute value of n. 4th root, so it's more than that 4 right here, of 2m squared. Remember that we still have this 2 over here. So the square, the absolute value is n. Remember this, the exponent 4 divided by the index. Right? So negative 12 squared, absolute value of n, 4th root of 2m squared. So 384 is 4 times 96. So this is 2 times 2. This is 8 times 12. So this is 3 times 4, 2 and 2. This is 2, 4, 2 and 2. So I have 1, 2, 3, 4, 5, 6, 7, 4, 5, 6, 7 times 3. So I have 1, 2, 3, 4, 5, 6, 7 twos. 2, 3, 4, 5, 6, 7 times that 3 over here. Okay? So again, I'm forming groups of 3 because my index is 3. So I have one group of 3 of, then I have a second group of 3 of 2s, of 3 2s, right? And then I remember that 2 and 3, right? So I have outside negative 3 times 2 times 2, right? The u, again, my exponent is less than that one, so that means that it doesn't simplify, but my v is more than, so 4 divided by 3 is 1, minus 3 is 1, right? So this is going to be v, and then the cubic root of 2 times 3 is 6 times u squared v, right? So this is negative 12v cubic root of 6u squared v. And in this case, because my index is odd, That's why we don't use the absolute value. Again, because the index of my radical is odd, we don't need the absolute value outside. So 108 is 4 times 27. So this is 2 and 2. This is 3 times 9. Again, so I have 2 times 2 times 3 times 3 times 3. Remember that when we're creating those groups, they have to be exactly of the same number. So I have three threes there, right there. Right? So that means that I have 3 times 3. Then the variables, again, x squared, staying the same. Y, we saw it earlier, that is y. It's cube root of 4 x squared y. As you can see right now, that those two are the two that remain. The next one. Now, because my index is odd, that means that I can simplify a negative number from inside. So 128 divided by 4. So negative 128. Oh, let's keep it positive. So we're just going to bring that negative outside. So this is 4 times 32. This is 2 times 2, 8 times 4. So 2, 2 times 4. 2 and 2 have 1, 2, 3, 4, 5, 6, 7. So 2. So now remember that now I'm creating groups of 5. So I have 1, 2, 3, 4, 5. Okay, so I have negative 2 outside. So because that negative, I'm going to bring it outside, so negative 2. My variable, none of the either variable has an exponent greater than uh, the index. So it's going to have, so inside, I'm keeping only 4 x squared y. So this is 14 fifth root of x. And that's it for this lesson. May the force be with you.